On Friday last week, we talked about solving exponential equations. And exponential equations are equations in which variable expressions occur as exponents. In other words, we need to solve for the exponent. And there's two ways this can be presented. One, it can be presented where you have an exponential expression equal to another exponential expression, such as this example right here. And if that happens, what we want to use is we want to use this property of equality, which states that if b to the x equals b to the y, then you know that x equals y. In other words, if your exponential bases are equal, then your exponents will be equal as well. And since that's where the variable is going to be, that's the part of the problem we would work. So if you look over here on the next page, you sometimes may have to rewrite so that you have a common base. For example, this problem has 2 to the x plus 1 equals 4 to the x. Well, 2 and 4 are not the same number, but there is a way I can rewrite this without changing any values and make those the same. A common base between 2 and 4 is 2. So this one I will leave alone. Instead of writing 4, I'm going to write that as 2 squared. That's what 4 is equal to, but now I have the same base. Once your bases are the same, you then know that your exponents are the same, and you can just work the problem with that. And then you're just solving for x, and so we will end up with x equals 1. Sometimes you have to change both of them. For example, on this one, I've got 9 to the 2x and 27 to the x minus 1. Well, the common base between 9 and 27 is going to be 3. I'm going to rewrite 9 as 3 squared, and I'm going to rewrite 27 as 3 to the third. The most important thing is you cannot change the value. Writing 9 as 3 squared doesn't change the value. They're the same value. Same for 27 and 3 to the third. Once you have the same bases, then you just focus on that part of the problem and solve for x.